Thank you, and welcome everybody. Glad you could join us today for the top 10 things you need to know. And real briefly here, just wanted to let you know that folks will have a chance to win a signed copy of one of my books, DB2 Developer's Guide, the latest edition of which was published recently, covering up through DB2 version 10 on ZOS. So at the end of the presentation, we'll provide a link where you can go and register to try to win one of the copies that DataVail has provided as a raffle for today's webinar. So with that out of the way, what are we going to talk about today? Well, we're going to look at a couple of top 10 lists. And really, the presentation says 3 sections here. Actually, it's 2 sections. We're focusing on developers and DBAs today. So what I tried to do was distill down into a list of 10 items for developers and then 10 items for DBAs that are the main things you really should focus on in order to have an effective, efficient, and reasonable environment for DB2 for ZOS, and make sure that you're doing the right things. And we're going to focus on a lot of different things in these lists, from performance and availability issues, to ease of use issues, even career growth type issues. So it's going to really pop all around the place, and hopefully by the end of the presentation, you'll have some things that you can do to further your career, to further the performance of DB2. Maybe some things you've already heard will be reinforced, maybe some new things, and hopefully you'll find it both educational and entertaining. So we'll start with the developers and looking at 10 things there on tips, techniques, tactics that you can use for better application development when you're using DB2 for ZOS. So we'll look at coding practices and career management, communication, and so on. With that said, let's start at the beginning and master the basics. Sometimes the basics may not seem quite as basic when you first get into DB2. You need to think about how you're going to write your SQL statements. Although simpler is better from an understanding perspective. You know, the more simpler the code is, the more you can understand it. From an efficiency or a performance perspective, complex SQL is the way to go. That means the more work you can put into the SQL statement, the more you're optimizing access to DB2 in general. Now, there are pitfalls along the way as you do that, of course, in terms of tuning the SQL, but really you should be focusing on, instead of breaking things apart and having lots of simple SQL statements, you should be looking at more complex SQL statements. Another way of saying it is let SQL do the work, not the program. This way, the DB2 Optimizer can take your SQL statements and figure out the best way to get to the data, instead of you breaking them apart in your program trying to figure out the best way to get to the data. A couple of subset rules to that, let SQL do the work. You want to retrieve the absolute minimum number of rows and only those columns that are required. So if you only need 3 columns, don't say select all of them. You really want to hone in on only what you want. Minimum number of rows is saying code the right where clauses. Instead of bringing the data into your program and then filtering it in the program, you want it filtered in the where clauses. Next, join predicates. If you've got a series of tables that are being joined together, and you should, this goes back to the first rule, let SQL do the work, do the joins instead of multiple SQL statements that are then cobbled together in the program. But when you've got multiple tables being joined in an SQL statement, be sure that you are providing appropriate join predicates. What do I mean by that? Well, if you have, let's say, table A, B, and C, you should have where clauses or on clauses, depending on how you code the join, that connect table A to B, table B to C, or table C to A, C to B. There should be a path through all 3 of those tables, or all X of those tables regarding the number of tables you have in the join. If you don't have join predicates, what you're doing is causing DB2 to do a Cartesian product. A Cartesian product says take all the rows in this table and join them to all the rows in that table, and it's going to take a lot of resources to do that and probably give you the wrong results. So whenever you've got joins, go back, check you got passed through your where you're on clauses. Next, stage 1 and indexable predicates. Stage 1 better than stage 2. We'll talk about in a moment what stage 1 and stage 2 are. Really what it's saying is you want to filter the data as early in the process as you can. And the earlier you filter the data, the less data that has to be moved from section to section of DB2. So it improves performance. Indexable predicates are saying that this predicate, this where x equals 5, x has, it can be indexed. You can use an index to satisfy the predicate. There are some predicates where even if you've created an index on that column, it's a non-indexable predicate. So favor indexable over non-indexable, favor stage 1 over stage 2. Additionally, hosted variable data type and length should match. Even though DB2 won't degrade that to stage 2 anymore, used to in older versions, it's still a good idea from the perspective of making sure you've got the right columns that you're joining. If the data type and length are different, you may be trying to do something that doesn't make sense. What you should do, whenever you go to a new version of DB2, search out the Managing Performance Manual, freely downloadable off the IBM website. Go to the table that has the list of all the stage 1 and indexable predicates. Print it off, that table, and give a copy to every developer in the shop. Make sure all developers have this, and tell them stage 1 better than stage 2, indexable better than non-indexable. Good rule of thumb. Avoid scans for large tables when and where it makes sense. You can't always avoid a scan, but usually an indexed access is better than a scan. Avoid sorting when possible. Look at using indexes for your order by and group by statements where you need to do sorting. If there's an index to support the sort, then DB2 can usually use that index and avoid a sort. Sorts cause a lot of overhead and in general are good to avoid. Distinct is another thing that can kick off a sort. Make sure you understand what distinct does. If I say select distinct, column 1, column 2, column 3, DB2 is going to sort to remove duplicates from the result set. If there could be no duplicates, or you don't care whether there are duplicates, don't code distinct. And then union all versus union. Union will sort to remove duplicates. Union all will not. So again, could be no duplicates, don't care if there are duplicates, use union all. It'll be more efficient than union. I said I'd talk about stage 1 versus stage 2. Real briefly, this picture depicts that. If we start at the bottom and move our way up, we have a SQL request coming in. Data gets read from disk by I/O into the buffer manager. In order to get that data back into the result, into your program, it has to go through the data manager and the relational data services. These are components of DB2. Okay, so just think of them that way. Stage 1 means that the SQL can be filtered in the data manager. Stage 2 means that the SQL has to be filtered in relational data services. So the earlier in the process, data manager, that you can filter the data, stage 1, the better. That's why stage 1 better than stage 2. Still within the basics here, number 1 on our top 10, it depends. Make sure you understand this rule. Basically, this is a valid response to most questions in DB2, but it's not the end of the response. It should never be, it depends, turn around, walk away. So if you're a developer and you've gone to your DBA and all they tell you is it depends, they're doing one of two things. Either they don't know the answer, so they just say it depends and walk away, or they're too busy to, or very busy, and they can't respond completely to your question. If the only answer you're getting is it depends, push, because that's not an answer. Sure, it depends, but what does it depend upon? That's what the crux of the answer should be. So it depends is a fine answer when followed by what it depends upon. It's a horrible answer when it's the end of the answer. So you're a developer, DBA says it depends and shuts up, push, because they didn't answer your question. Number 2 of our top 10 list for developers, understand the basics of the DB2 Optimizer. And this really applies to anyone using DB2, whether they're a developer, a DBA, a manager, an end user, what have you. If you're using DB2, you need to be able to look at this graphic and explain what's going on here. No pun intended with explain. In the middle, the DB2 subsystem, in the DBM1 address space, DB2 is composed of address spaces. One of them is the database services address space, or DBM1. In there lives the DB2 Optimizer. And the DB2 Optimizer has query cost formulas in it. In other words, rules that will take into account the cost of a query based on the type of data that's being accessed and come up with the best way to get to that data, an access path. So what we have here is in the middle is the optimizer. On the left-hand side is all the stuff being read into the optimizer. Your SQL statement or statements, the DB2 catalog, statistics that have been gathered by run stats, other system information, what type of processor are you running on, how much memory do you have allocated to buffer pools, and so on, and possibly a hint. All this gets read into the DB2 Optimizer. Out the other end comes the red box at the bottom right, optimized access paths. So whenever a statement, whether it's dynamic or static, a dynamic one goes in and is optimized at runtime, a static goes in and is optimized at bind time, comes out with optimized access paths. If you say explain yes, you also get plan tables, and there are multiples of them that are populated with information that tells you what DB2 chose to do in the optimized access paths. That's the high levels of the optimizer. Realize, too, that understanding the high level of what the optimizer is doing is generally sufficient for developers. It's not really possible, at least not 100%, to figure out exactly what the optimizer is doing at all times. Only IBM really has that information, and IBM doesn't publish the source code of the optimizer. So understand what the purpose of the optimizer is, understand the trends and what the optimizer chooses based on the type of queries you have and the type of data you have in your applications, and then do as much work as possible within your SQL to ensure that the optimizer is going to come out with access paths that are reasonable for your set of application access and data. The general rule at the bottom of the slide is one you really need to take to heart. DB2 code is going to be usually more efficient than any code we attempt to write. So let the optimizer make the choices. Number 3, and this is really more for people who are newer to DB2 or newer to relational. Maybe you've spent a lot of time working on flat files and COBOL processing in a mainframe environment. You need to unlearn that flat file mentality and learn to join. This gets back to some of the basics we talked in rule number 1. Master file processing is not appropriate if you want to optimize your application code going against DB2. An open cursor is not the same as an open file. You know, you open a file and pop through it. Open cursor causes sometimes a lot of work that gets to be done to get the result set available to be fetched from. So a lot of times people are coming from this COBOL flat file environment will say, all right, open up a cursor, read or fetch from it, use it to drive another cursor. That's master file processing against flat files, and probably something you want to avoid in DB2. Instead, code those as a join. A lot of reasons why that's the case. The database is not a set of files. Databases have relationships. Tables are not files. They're based on sets. Sets are not ordered, and they're all of the same type. And when you perform an operation on a set, the action happens all at once, theoretically, to all members of the set. Rows are not records. Columns are not fields. So we're operating in a different paradigm when we're talking about a relational database like DB2. So unlearn the flat file mentality. We talked about stages 1 and 2. I want to briefly introduce stages 3 and 4 too. Stage 1, more efficient than stage 2. Stage 3, this isn't documented anywhere, this is just my shorthand. You can think of that as moving predicates from SQL into your programs. In other words, instead of putting it in a where clause, you've put it into a simple SQL statement, and then in your program you may have if then else or case logic that is going to look at the data that's been fetched and see whether it applies. This is bad. We don't want to do that. Think of that as stage 3. 1 better than 2, 2 better than 3. So a stage 2 predicate shouldn't be avoided and then moved into your program. Stage 2 is still better than stage 3. Finally, we've got black boxes, and this is number 4, and we're talking about what I like to talk about as stage 4. Avoid black boxes. All right, what is a black box? Well, a black box is where someone in your organization, usually a manager, gets a bright idea that says, instead of writing SQL in my programs, I'm not going to have my developers write any SQL. I'm going to have this piece of code that all the developers will call, and the code will have all the SQL in it and send the data to any program that makes a call to this black box. This is bad for a lot of reasons. Number one, it's bad because you are leaving your developers in the dark, and they may be requesting data without any knowledge of what actually is happening to get that data. So, you know, a 12-table join needed to get this piece of data, send it to the black box people and let them figure it out. Secondly, the black box is a bad idea because usually the coders of the black box will take shortcuts, and all of the things that we talked about earlier in terms of mastering the basics get thrown out the window. It's human nature. You're the guy, you're working on the black box code, and a team comes to you and says, I need customer data, I need these 5 columns. Okay, another team, I need these 12 columns of customer data, and another team comes to you and says, I need all 50 columns of customer data. Human nature being what it is, if everything else about the SQL is the same, you'll code one SQL statement. Send team 1 the 7 columns, team 2 the 12 columns, and team 3 all 50 columns. And then by design, you just build bad performance into your application because you didn't follow the rules we talked about earlier, retrieve only the columns necessary. Also, a black box has code in it that would never need to be executed if the SQL was just put into your application program. There's code that would be required to get to the SQL statement and to return the right data to your program. This is path length that gets executed that doesn't need to be executed. Finally, black boxes are basically building an access path to data, an API into the data of your DB2. That's what SQL already is. So it's redundant and it's unnecessary and it shouldn't be done. If you're interested, the URL at the bottom of the screen has an article where I talk about this in a little more depth. Number 5, from a developer perspective, is learn how to code for null. Null is an absence of a value, and it's not the same thing as a 0, not the same thing as an empty string. I never call them null values. I know this is common in the industry, but it's a null lack of value, if anything. There is no value when you have a null. All right, if you disagree with me, let's think about it this way. There is a personnel table in your organization where you work. In that table is a column called termination date. What would you like your termination date to be set to? Null or a valid date? Even if it's a valid date way in the future. I don't know about you, but I want mine to be null. Null meaning unknown, no value. Haven't fired this guy yet. Whereas a valid date in the future, that doesn't sound so good to me. All right, how about salary? Same table, personnel, column for salary. Want it to be set to null or 0? Well, my answer is neither one of those are really too palatable. But given those as the only two options, I'll take null, where null means I don't know. And if it's 0, it says I do know, and you're getting nothing. So other examples, Social Security number for a non-U.S. resident, or what about hair color for bald men? Here's an example where I think null is bad. Null is saying no value. Null would be good if I said, I don't know this person's hair color. Where you have control of the domain, where you're creating values for hair color, bald would be a perfectly acceptable value for hair color. So when you have control of the domain, and there's an option that you can put in there, that's great. Use null for I don't know or not supplied, not lack of something like bald hair. Okay, for when you code for null, you have to realize all data types include the possibility of having a null set for them. This is done using a null indicator. It's 1 byte. 0 or positive means not null, whereas negative value means null. This is not stored in the column, but is associated with the column and managed by DB2. A program has to be explicitly coded to deal with the possibility of null. So if you take a look at the SQL bottom right of this screen, we see salary could be null. So we select employee number salary into employee number salary and salary indicator from the employee table. A common error here is to specify the indicator, but then you don't check it when you read the data into your program, and just use whatever is specified in the salary column instead of checking is salary indicator null. Garbage will then be returned to you. So make sure when you code the indicator that you check the indicator. If you don't specify a null indicator or a null structure, and the column is nullable, or the result could be a null, you will get a negative 305 SQL code returned. So you have to be careful and check for that negative 305. Coding for null, a little bit different. You can't say on the bottom where salary equals null. There's a special operator where salary is null. So nulls are treated differently. Remember, nulls are a lack of value. Comparing values, you might get confused and say it's a little bit inconsistent because the null never equals a null in predicates. When both of the sides of an equality predicate are null, it's unknown because there's lack of value. However, nulls are treated as equal for sort order. So they sort and group together in order by and group by statements. There are another couple situations where they're considered equal when duplicates are eliminated by select distinct or count distinct, and in unique indexes that do not have where not null specified. So you got to understand how DB2 treats these. So they may look inconsistent, but as long as you understand how DB2 is operating, it's fine. A few more things about null. Top, what is the result of null divided by 0? The result of null in any arithmetic expression is null. It's not an error, like any value that could possibly put in there for null would return an error. But dividing by 0 is not an error when null is on the top of that division. So any null in an arithmetic expression is null. Keep in mind that the grouping functions, average, count distinct, sum, max, and min, will omit column occurrences that are set to null. So for that reason, average of column A is not necessarily going to be equal to sum of column A divided by count asterisk. Sum of column A counts values, count asterisk counts rows. So if there are any column A instances that are null, average of column A will not equal sum of column A divided by count asterisk. You would have to say sum of column A divided by count of column A. Finally, take a look at the select statement here in purple. If I say select sum of salary from employee where department number is greater than 999, And for this instance, let's assume salary in the table is defined as not null. This statement can return a null. When there's no department number greater than 999, select sum salary will return null. It won't return 0. It will say it's the empty set, null. It won't say 0. If there were department numbers greater than 999 and the salaries were set to 0, then sum of salary would equal 0. But if there are no rows that apply to the where predicate, the result is null. A lot of people get the negative 305 by not coding a null indicator on this type of SQL statement. And something like this could possibly run in production for years until such time as if the 999 is a host variable, someone enters something into that host variable that causes a null to be returned by the sum. So whenever you're using functions, code null indicators. Number 6, avoid Bachelor programming syndrome. What's that? That's fear of committing. Every program that modifies DB2 data should implement a commit strategy, meaning after so much time goes by or after so many modifications are done, a commit is issued. If you're not doing this, chances are your program is going to run, but you're going to impact everyone else in the shop trying to access the same data. So you'll wind up getting timeouts and deadlocks, usually not for your program because you're hogging all of the data and keeping the locks, but for other programs trying to access it. So issue commits in your batch programs. Guidelines, your mileage may vary. These came out of my book, DB2 Developer's Guide, and maybe you want to have something, generally speaking, I think a good idea would be a parameter where you can control how often the commit occurs, and you can set that as it runs. Know the SQL tweaks, number 7. There are shorthand tweaks that can be applied to kind of coerce the optimizer to make specific decisions. Optimize for one row. You're telling the optimizer, I'm really only trying to retrieve a small amount of data, and this should usually eliminate list prefetch. And you might want to do that in an online environment. No ops, adding or subtracting 0, multiplying or dividing by 1, concatenating the empty string. This makes the expression non-indexable. Arithmetic expressions are non-indexable. Even though, as of version 5, some arithmetic expressions, non-column ones, are indexable, IBM has specifically accepted these no-ops because people use them as ways to tweak the SQL. And here's an example where we're concatenating an empty string to the last predicate, and that's disabling matching index access, but it will leave that predicate stage 1. Scalar functions are another type of tweak. It renders the predicate non-indexable, can work like a no-op, unless, of course, you created an index on the expression, which came in a couple releases ago. But if you just have indexes on columns, this will work. Here, if 2 indexes exist, one on last name and one on salary, and DB2 is choosing the salary index instead of the last name, you can pop out salary greater than 5,000, put the decimal DEC function on it, and that will work as a way of trying to tweak DB2 to use the last name index. Join order, sometimes you might want to influence that. Usually we want the table with the smallest number of rows that qualify to be the starting table. You can add more predicates to make the optimizer think that the number of rows has been reduced, or you might make the join predicate on top, table A non-indexable to try and force that. Dynamic versus static SQL, number 8. For the most part, new types of applications that are done are being written for dynamic SQL. Dynamic SQL is different than static. Instead of hard coding, it's kind of built on the fly, and it's optimized at runtime, whereas static is hard-coded and optimized at bind time. There are options, though, where you can use static or use dynamic, or make static more dynamic, make dynamic more static. Here's criteria where you might want to think about dynamic instead of static. Dynamic incurs a higher initial cost because of the prepare, but once it's prepared, the difference in execution time diminishes. So keep that in mind when you're saying dynamic may not be as optimal as static. Dynamic can result in more efficient access paths than static when the data is non-uniformly distributed. What do I mean by that? Well, cigar smokers skew male. Or whether the data is correlated. City, state, and zip code are going to be correlated inside the row. Range predicates. The more frequently you need to use range predicates, the more you should favor dynamic SQL. Repetitious execution. As the frequency of execution increases, you want to favor either static or dynamic with local dynamic statement caching. Again, keep in mind the cost of the prepare becomes smaller as a percentage of the overall runtime the more frequently it runs, as long as it's cached. When you need all or part of a SQL statement to be generated during the execution of the application, obviously dynamic better than static. Dynamic also can be the answer when you need to build an application where the objects may not exist when the application is first being precompiled. It might be a better option than specifying validate run with static. And frequency of run stats. When your application needs to access data that changes really frequently, you might consider dynamic SQL. Number 9, multi-row fetch. This is a really good way of optimizing batch applications that access a lot of data from cursors. If you've got multiple rows, getting them one at a time, take a look at moving to a multi-row fetch. This is showing a single row fetch. We start off, we fetch a row, we fetch another row, we fetch another row. And this work in between the program and the DB2 result set consists of overhead as we go back and forth between the program and DB2. Multi-row fetch, on the other hand, you get 10 rows, bang, all at once. So instead of going back and forth between DB2 10 times to get each row, you go back and forth once to get 10 rows, and you keep going as you work through the fetches. So CPU can be greatly reduced when you move data across multiple address spaces using multi-row fetch. The downside is you've got to code more in your application program. So you bring back multiple rows, and then you go through the array that was brought back in DB2. So there's a little more coding that you have to write. Generally speaking, from the red books, it says you can get between 50 and 60% performance improvement. I've spoken to people who have done this and gotten extreme performance improvement in their batch applications. So where you've got a lot of data being read, it's a good idea to take a look at, can we move to multi-row fetch? And number 10, the last for the developers, is keep current. One of the biggest detriments I've found out there is that a lot of times developers are so busy writing code that they might not always keep up to date on what the latest features of DB2 are. So they wind up writing code like they would have in an older version of DB2. Whenever you get a new version of DB2, train yourself on the new SQL functions. Look at the new techniques. You can download the What's New manual. There's usually a section in there talking about SQL or development, and just making yourself familiar with them for when you go to that new version can save you a world of effort and improve performance significantly. Okay, on to the DBAs. We've looked at the top 10 things for developers. Let's focus now on top 10 things for DBAs. Number 1 is know both database design theory and practices. Sometimes you got DBAs heavy in theory. Sometimes just heavy in usage of a particular DBMS. You need to know both to do the job right. So modeling, normalization, database design, you need to know how that works and how that operates and how to take that information from a data administrator or a data architect and build it in DB2. You want to make sure, though, that as you take that, you are using the features of DB2 as they were designed and meant to be used. In other words, you've got chronological data, date, time, timestamp. Don't force it into a character column. You got numeric data. Put it into the numeric data type. Don't force it into an alphanumeric or a character column. You got multiple buffer pools. Don't force everything into just a few. And use RI. The database constraints improve data integrity, and data integrity is the #1 thing that a DBA can do to offer accurate data to the organization. That's the purpose of the DBA. They're the custodians of the database. So referential integrity, check constraints, triggers can be designed to make sure that the database is proactive in maintaining quality data. Avoid the defaults. They're usually wrong, and even when they aren't wrong, explicitly code it. It's good for documentation and for understanding what every feature is that you're selecting and asking DB2 to do. Free space. Choose %free and free page wisely. Don't just default it to 10 and be done with it. Static data does not require free space. If you've got a table that has the 50 states of the U.S. in it, no free space. %free 0, free page 0. Don't use free space. When we add a state to the union, I guarantee we'll give you time to reorganize that table. And plan for purging and archiving of data up front as you're designing the database. You don't want to have data just continually add up and add up and add up in a production environment and impact performance. Purging it if you can, archiving it if you can't, just to keep it around is archiving it, purging it is getting rid of it. If you don't plan that up front, the data never goes away and it just builds up. Compression, not just for very large objects anymore. Any table space that has more than 50 pages, take a look at compressing it. It can even improve performance because you get more rows on the page. Look at using DSN1 comp to evaluate compression gains. And realize that universal table spaces are the future of DB2. Use range partitioned where you used to use classic. Use partition by growth where you used to use simple and segmented. The only option right now for a multi-table table space is segmented. So that's really the only caveat to this rule. And eventually you will see multi-table universal table spaces. Know the difference between importance and frequency. What's the most important thing that a DBA does? Usually people here say, well, performance. And what you're doing is confusing importance and frequency. Yes, you probably are doing performance management and tuning more frequently than you're doing other things. But really, the most important thing that a DBA does is ensure the integrity of the data, whether it's the accuracy and availability of it, like I was talking about with check constraints and referential integrity, or it's backup and recovery, making sure that if something goes wrong, you can recover that data to the point in time, to the recovery time objective of your organization. These are the most important things you do as a DBA. Anyone can deliver performance to the wrong data. Making sure it's the right data, there's the challenge. Don't be a hermit. DBAs have this reputation as curmudgeons. That's not a good thing. You want to walk around. You want to understand and interoperate with people. You don't want to be this angry guy in the corner saying RTFM, which we all know stands for Read the Friendly Manual. No, you want to, if you tell them to read the manual, tell them which manual to go, where to go to. You know those manuals better than the developers do. You're there as an assistant. You're there to help the applications be written against the data. Without the applications, the data doesn't matter, right? So share your knowledge and experience. Be viewed as helpful instead of as a curmudgeon. But be careful of standards. To me, my favorite quote is, the best thing about standards is that there's so many of them to choose from. Having DB2 standards for your shop isn't a bad idea. However, making them flexible enough so that it's possible for there to be an exception is fine. What you don't want is standards written in a manual, put on a shelf, and not looked at for the next 20 years until someone comes by and blows the dust off of them and says, hey, what are these? Your standards should be a living, breathing thing that are there to make sure that DB2 is efficient, effective, and useful and usable. As a DBA, realize you can't know everything. So instead of trying to know everything, know where to look. The Information Center Online, everything's there that you might need to know. The manuals. I like going and downloading the manuals for every new version in PDF form onto my hard drive. Yeah, they change over time, and I usually have multiple versions of the manuals over time, but this can be a good thing because if you don't have access to the internet, you got the PDF file with you. DB2 books. Hey, I think I know a good one. And also know who to call for assistance, either internally at your company, whether it's as a DBA you're looking for information on KICS or MVS or ZOS, the systems programmers, the capacity management people, the storage management people, or externally in your network of contacts outside the company, DBAs you've met at IDUG, DBAs you've met at regional user groups. It's good to have a list of those folks. Okay, the tuning progression. Now this is something that you get sit down in a situation where someone comes screaming into your office as the DBA and they say, "There's a problem with DB2." No one ever comes running into your office and says, "There's a problem with this really horrible code I wrote. Could you help me out?" No, there's a problem with DB2. So what do? Where do you look? Well, in terms of problem resolution, you start at the top of this chart and move your way down. Look at the application, the SQL, the host language code. 75 to 80% of problems are going to be in the application code. So start there. If you don't find the problem there, look at the database. How is it organized? Do we have appropriate indexes? Indexes straddle application and database. But then look at the organization of the indexes in the databases. Do we need to run a reorg? Have we run appropriate run stats? Hopefully we don't have a normalization denormalization issue in a database design problem, because that can be sticky to solve. So start at the application, move to the database. Don't find the problem there. Look at the subsystem. ZPARMs, locking, DDF, buffer pools, sort pools, RID pools, IRLM, all of those things could potentially cause performance issues. And it's still possible, if you don't find an issue there, that you've got an issue in the environment. In other words, things that interoperate with DB2. The network, the TP monitor, KICS or IMS, your operating system, your networking in terms of internet access, storage, JCL, things outside the control of DB2 still can cause issues. So in terms of problem resolution, start at the top of the chart, work your way to the bottom. Another way of looking at this chart is severity of problem, and that's bottom to top. If you've got an issue in the environment, maybe an operating system issue or a KICS issue, chances are it's impacting multiple subsystems, multiple databases, multiple applications. So it's more of a severe problem. And as you work your way up the list, the same thing. A subsystem problem can impact multiple databases, multiple applications. A database problem can impact multiple applications. So the more further down the list we go, the more severe the problem. So think of it, to resolve the problem, start at the top, go to the bottom. In terms of thinking about the severity of the problem, start at the bottom, go to the top. Some basic tuning rules. Can't sit here and give you guidelines for every problem you're going to have, but basic rules, 80-20 rule. It applies because it is throughout the industry applicable. 80% of the results come from 20% of the effort. Or 20% of your apps are going to cause 80% of your problems. So don't try to boil the ocean. Focus in on something that's going to give you the biggest return on investment. Tuning is an iterative process. Tune one thing at a time. You don't want to go and say, change an SQL statement, add an index, change a buffer pool, now let's see what happened. Every one of those things could be an appropriate tuning approach. Do one, test, see if it helps, see if it hurt. Do another, test, see if it helps, see if it hurt. Also keep in mind that all tuning optimizes CPU, I/O, or concurrency, or a combination of these three things. You want to be decreasing CPU usage, decreasing I/O, and increasing concurrency. If you're making a change and it's not doing at least one of these three things, fine, it's a change, but it isn't performance tuning. As you're approaching tuning, number 8, remain calm. The more you can remain calm, the better you're going to be. You don't want to rush to a solution. Take the time to soak in what the problem actually is. Realize that sometimes doing nothing is the answer. You need to contemplate problems. Realize some problems solve themselves, not always, but also make sure that before you go in and start making changes that you have thought out what the problem actually is and why the change you're going to make could solve that problem. Otherwise, you're running around like a chicken with his head cut off, making changes that might even exacerbate the problem. Number 9, be a jack of all trades and a master of some. You want to master DB2. You want to master SQL. You want to master database schema. You also want to have a working knowledge of some other things that interoperate with DB2, whether it's XML or Unix or COBOL or even another DBMS like Oracle or SQL Server or Informix or big data, and realize that as a DBA, you're kind of at the center of development of your organization, and the more you learn about more technologies and things that are even peripheral to DB2, the more valuable you make yourself to your organization. So be that jack of all trades, as long as you master the DB2 and the SQL. Finally, for the DBA, document and automate. Write everything down. If you document the process used to resolve problems, you'll be prepared the next time it comes up. Also, once it's documented and available to other DBAs, they can benefit from your experiences. Keep everything. It's a good practice to keep everything. A DBA should be a pack rat. I've got DB2 version 1.3 manuals in my garage. And this is, yeah, it sounds sick, and my wife will tell you it is. But at one point I was contacted by a law firm that was looking for really old documentation, and I was able to benefit from having access to that information in terms of getting a consulting gig where I wouldn't have otherwise. So my wife is more accepting of my pack rat ways, as long as I keep it in the garage and not in the house. And automate. Why should you do it by hand if you can automate your DBA processes? Anything you can automate, the better it's going to be to turn your attention to more sticky problems and scenarios. And that is the top 10 for DBAs. We looked at the top 10 for developers, and that kind of brings me to the end of the prepared remarks today. As I promised, I'll give you a link here, info.datavail.db2/db2_book. That's db2_book is the link that you want to go to register to win one of 5 free copies of my book. I'll get it autographed for you and send it out to you when DataVail notifies the winners. Contact information for myself and for DataVail. And very briefly about DataVail, they are a pure-play remote DBA services company. They have DB2 for LUW and ZOS services, as well as other DBMS services, whether it's Oracle or SQL Server or MySQL, even MongoDB and SharePoint. They've been around for 7+ years, and info@datavail.com if you're interested in more about DataVail. And with that, I'd like to thank you for joining us today and open it up for any questions.
Thanks so much, Craig. We have had a few questions come in, so we'll jump right into the Q&A period. But before we do that, I just want to remind attendees, if you have questions, now is the time to ask. So the first question we received was, so would you consider IBM's VT a black box to avoid?
IBM's what?
VT, and in parentheses, it's explained VSAM transparency.
Oh, VSAM transparency. No, not necessarily. VSAM transparency may or may not be the right answer depending upon how complex your VSAM files are. Usually VSAM transparency can work reasonably well for simple VSAM files. For those of you who don't know VSAM transparency, what it does is it converts your VSAM to DB2 kind of, so you can have your program still remain VSAM access, convert the VSAM files to DB2, and VSAM transparency will take the VSAM read and convert it into a DB2 select. So, you know, at a high level, you can think of it as kind of a black box, but it is a vendor piece of code, and it is something that is geared for a certain situation and can be a reasonable approach. When I talk about a black box, I'm really talking about you're building a new application, and you're creating DB2 tables, and instead of accessing them inside of your programs with SQL, you are creating this black box. I actually worked at a company where they wrote one, and they called it the thing. Even the documentation says, then you call the thing, and it really lived up to its reputation. It was a thing. So when it's writing these type of things, I'm not really talking about vendor code. I've gotten questions like that too about Hibernate, and Hibernate, it can write some crappy SQL, but that's not what I'm talking about when I'm talking about a black box.
Okay. Which one is more efficient, if null or checking the null indicator in program and setting the salary to 0 if null?
Well, what I'm going to say is it's going to depend on how you want to use it. I think they're both going to be reasonably efficient. What checking this null indicator does is it actually tells you that there was a null there. So if you care that there's a null there, then checking the null indicator is the way to go. Whereas using if null or another function like coalesce to change the value from a null to a 0, what that will do is actually convert the value and not really tell you that there was a null there to begin with. So if all you care about is getting that to a value, using the function is a fine way of going about it. I don't think that performance is something that should generally be brought into it when you are determining which one of those to use. It's what type of processing do you really want to do? Do you just want to convert it to 0 and treat them as zeros and don't care whether there was a null there to begin with? Use the function. If you really care to know that there was a null there, check the null indicator.
Hey, Craig, could you just go back one slide? We've had a lot of people asking for that link to enter the drawing. I just want to let attendees know as well, you'll get a follow-up email which will include this link for you to click on directly. So while you're all writing down that link, we'll jump into another question. What about using column with default value instead of null value? It becomes to me to implement easier in application programs.
Okay, so this is talking about in the DDL when we're specifying the column. There are 3 things you can specify. You can specify nothing, which would mean it's nullable. You can specify not null, which means it can't be null and you have to provide a value. Or you can specify not null with default, which specifies that you can provide a value, but if you don't, you're going to get a default actual value, which could be 0 or spaces or the current date, depending upon the actual data type of the column, or you could actually provide your own default value. So you say with default X, and that could be for a character column defaulting to X. And that's a perfectly valid approach to choose. Sometimes when earlier in the presentation I said avoid defaults. I'm not talking about this particular instance, not null with default. That's a perfectly valid choice based upon your application needs and how you treat the data. So if when you don't have a value provided, it's perfectly fine for you to specify a default and use that default, and your application is comfortable doing that and has done that, that's absolutely valid. The one I think that's tricky is where you use a date or a time. And the default there is generally going to be the current date or the current time. Yes, you could provide your own specific date or time, and that would be a way to default that. But when you're talking about those types of data types, you really don't have control over the domain. The domain's controlled by DB2. So a null there, again, depending on the application, how it's used, and where and when that data gets read and processed by the application. I can't just say always do this or always do that, but not null with default is a perfectly valid and fine option. as long as you're not using it to say, I can't have any nulls anywhere.
Okay. Does size of the table matter for performance? Let's assume I'm not scanning. It has status. So will making the table smaller make my application faster?
There are all different kinds of reasons why the answer to that could be yes or no. In general, I find it a valid rule of thumb to keep the table size as small as you can without compromising the integrity of the application or the business need. You need the data there, the table needs to be huge, fine. You got a business purpose for that, that's absolutely fine. And there are techniques you can do to optimize the SQL, optimize the indexing and the processing to try to optimize your access. So from an application perspective, if you're doing get in, get a row, get out, and you have an index built on the where clause, then that's going to be generally as efficient against a big table as a small table. With some caveats, I mean, how the data is laid out on disk, and today we've got RAID devices, and that's a difficult thing to figure out anyway. So there's, the bigger the data is, maybe the more control structures behind the scenes that may have to be parsed in order to get the data. But that's not usually a big issue. The big issue then becomes the utilities we run against those tables or table spaces. If we've got a very big table and we've got data in there that we never access and we're never going to access from a business perspective, even if our application is running efficiently from an application code perspective, every time we image copy that table, we're doing more processing than we need to do because we're copying data that never changes. Every time we reorganize, every time we run stats. So utility processing can add up and cause issues. So even if you've got your application optimized, it still can be beneficial to look at ways to reduce the size of that table with either purging or archiving if the business allows it, if the regulations allow it, and it makes sense.
Great. I think we have time for one more question. And Carla asks, I am seeing programmers using multi-row fetch when the results are expected to be very small. How much does this affect performance?
When you say very small, I guess a lot depends on what you mean by very small.
She explains it as 2 to 3 rows.
Generally speaking, that's a lot of additional code and overhead that really isn't causing you a lot of help. In terms of, is it causing you overhead by doing it, I'm going to give you my gut reaction, which is probably a little bit, although I don't know for sure. I haven't actually run any tests on those small amounts of access. So my advice would be, if it's always 2 or 3 rows, and you're never getting up in the 50 to 100 rows being fetched from that cursor, the benefits of multi-row fetch are not being achieved by that program, and you may be better off getting it out of there.
Great. So I'd like to extend a special thank you to Craig Mullins for presenting today's session. Thank you to all attendees for joining today's iDoug webcast. If you have any questions that were not addressed during this seminar, please email them to me at idoug@idoug.org. You will receive a follow-up email soon. This email will include a link to access an evaluation for this webcast. Please complete this evaluation within the next 2 business days. Your feedback is important as we further develop the iDoug webcast content. Just a reminder, 5 winners will be drawn to win a copy of Craig's book, DB2 Developer's Guide. To enter the drawings, please click on the second link provided in the message and enter your information. Thank you for your time today, and have a wonderful rest of the day, everyone.